Good day, viewers. You are welcome to today's teaching. In today's teaching, we'll be looking at coordinate geometry. Coordinate geometry. Another, we'll be looking at distance between two coordinates. Distance between two coordinates. This geometry focuses on the distance between 2 points. That is coordinate geometry. And the first thing we'll be looking at distance between two coordinates. Now here we are going to use this parameter that we call horizontal axis and vertical axis. The horizontal axis is what we call the x coordinate, while the vertical axis is the y coordinate. So the distance between two coordinates. This is the vertical axis, and this is the horizontal axis. Here is our y, here is our x. Now, the 2 points, let's say the 2 points are these. That is point X to point T, for example. Then we have a thick line to get a slope. This is the distance between two coordinates. Here we have y-axis, x-axis. Here we have it as x2 minus x1, and here we have it as y2 minus y1. So if we trace this one out, let's use dotted line. This is our y2 on y coordinates. If we trace this one out, this is our x, our y1 on that y coordinate. If we trace this down using dotted line, this one is x1, that is on x coordinate. We trace this down, this one is our x2. Now, how do we determine the distance? So there is a formula using Pythagoras theorem. You know, a right angle is formed here, triangle, indicating angle 90 degrees. So how do we get this? That means that using Pythagoras theorem, this is the hypotenuse. It means that xt squared, the distance st squared, I put it in brackets, okay, is equal to our x2 minus x1 squared plus our y2 minus y1 squared. So what is the meaning of this x2 minus x1? That is change in x coordinate and y change in y. That is increase in x coordinate and increase in y coordinate. Now we take the square root of this to get our distance st, which is equal to the square root of s2 minus x1 plus y2 minus y1 squared. So this is the formula used to find the distance between two coordinates. On y-axis, which is also known as y-coordinate, x-axis, which is also known as x-coordinate. Now, if we are to solve a problem now, example, we have to find the distance. Find the distance between point A, where we have it as 1 and minus 2, and point B, where we have it as 5 and the minus 5. So how do we solve this problem? Indicate this that is related to y coordinate and x coordinate. Here we are having this one as x1, comma, y1, then here is x2, comma, this place is y2. So you have indicated the x and y coordinates. So from here, our 1 and minus 2, we have it as x1, y1. Here, we have 5, minus 5. And then we have it as x2, y2. You just bring it back to this. The distance, you can use the distance that you have to find is equal to the square root of x2 minus x1, remember to put your square, plus our y2 minus y1 square. So that means our distance is equal to, let's put the square root. What is our x2? Our x2 is 5 minus 1. Our h1, put it into bracket, square, plus, into bracket, our y2 is minus 5 minus 2. Let's put it into bracket, square. So what are we going to have now? Our distance is equal to 5 minus 1 will give us 4. That's 4 square, plus, into bracket, minus 5, minus times minus will give us plus 2, everything into bracket, square. Then our d, the distance now, will be 4 square plus minus 5 plus 2 will give us minus 3 square. Our distance is equal to the square root. 4 square is 4 times 4, which is 16, plus minus 3 square means minus times minus will give us plus. 3 times 3 will give us 9. That means our distance is equal to 16 plus 9 will give us 25. Our distance is equal to, the square root of 25 is equal to 5. That is our final answer. That is, the distance between the point A and B is 5. That is the distance between two coordinates using this formula. Now, the next thing we are going to look at, the midpoint coordinates. The midpoint coordinates. So looking at midpoint coordinates, the formula is a little bit different from what we have here in midpoint coordinates. That is, we are talking about the middle part of the y-axis and the x-axis, which I interpret to be y coordinate and x coordinate. So midpoint is equal to, from the word mid, the middle point. For example, when we have a straight line, the midpoint of that straight line is equal to half, that's the middle of middle, into bracket x2 plus x1, let's go comma, then also y2 plus y1. Now, what's going to be the interpretation of this now? The interpretation now will be x over 2, x2 plus x1, x2 plus x1, everything over 2, divided by 2, comma, then y2 plus y1, everything over 2. That is the midpoint of a straight line coordinate, the midpoint of a straight line. Now, for example, class, if we are to find the midpoint, between A, which is where we have 1, comma, and we are to find the midpoint between these two distances, or distance here and this one, the distance A and distance B. So how do we do that? We follow that formula, midpoint coordinate. That means that the midpoint is equal to x2, let's start with our solution. Now, what is our x2? Like the way we labeled what we did the other time, the way we labeled what we did the other time. Here is x1, we have our y1, x2, y2. So what is our x2? That will be 2 plus 1. Comma. Then we also have our y2 to be 5 plus 1. So that means we are going to have 3 over 2, comma, then we are going to have 6 over 2. So from here, our 3 over 2, you may leave it, you may not further reduce, but this one can still be further reduced. So that means our midpoint is equal to 3 over 2, comma, then 2 here, 1. 2 is 6, 3. As the final answer. So look at the formula for midpoint coordinate and how to solve problem on this. It looks like a graph, a graphical solution where we have x coordinate and y coordinate. Now here we are going to also look at gradient of a straight line. Gradient of a straight line. In our straight line equation, you know the equation to be y equal to mx plus c. That is, y is equal to mx plus constant c. Our straight line equation, we have it as y equals to mx. What is this n? This n is the gradient. Another word for gradient is what we call slope. Slope of a straight line is, this is the slope. We have this as the slope. In the straight line equation, our constant is seen as what? 0. Constant is 0. Then, now if constant is 0, that means that y is equal to what? Mx. And I've told us that this is the gradient, which is also known as what? Slope. So if this is the slope, we want to make this the subject of the formula. We divide both sides by x. Divide both sides by x. Divide both sides by x. This will go. Our m then, and which is the slope, is equal to y over x. And what is the interpretation of this y over x? It means change in y over change in x. Change in y over change in x. And what is the interpretation of that? That is increase in y over increase in x. From the y coordinate, the increase, that is y2 minus y1. Then x coordinate, increase x2 minus x1. That means that our m, which is the gradient of the graph, is equal to y2 minus y1 over x2 minus x1. Now, for example, find the gradient of find the gradient of a straight line. When we have a straight line, the gradient, this is the interpretation. Let me first write my solution. This is the interpretation. The interpretation is this. We're having this, and we're having another point. Then we bring down this to locate our slope. Like I said earlier, that gradient can also be seen as the slope of a straight line. So here, remember, from the section of this class, I said this is the x2 coordinate because it's on x-axis. Then we have this at x1. Then we have this using dotted line to be y2. Then we have this using dotted line to be y1. Now, what is the interpretation of this? Remember, from here, our x1 is this, our y1 is this, our x2 is this, while our y2 is this one. Now, what will our s1 be here? Our s1 is 1. That means it's located on one axis here, while our x2 is on 3 here, while our y2 is this one, which is 6 here, and our y1 is 2. Now, how do we determine this? It looks like a graph. This looks like a graph. To determine slope of a graph. So, from this, our formula, where I said it the other time, that we have change in y over change in x. That is increase in y over increase in x. That means that the gradient is equal to y2 the gradient is equal to, from that solution, y2 minus y1 over x2 minus x1. So, what is our y2? Trace it to that straight line. We have it as 6 minus, our y2 is what? 2, everything over, what is our x2? Our x2 is 3, minus, what is our x1? We have it as 1. 6 minus 2, what will it give us? It will give us 4. 3 3 minus 1 will give us 2. 2 here, 1, 2 here, 4, 2. So that means the gradient of that straight line is 2 as the final answer. We have the gradient, which is the increase in y, that is y coordinate, over the increase in x coordinate, which is y2 minus y1 over x2 minus x1. So we indicate our x1 and y1 according to the point given in the question. That is 1 and 2 in point P, then 3 and 6 in point Q. So we find the distance, or we find the difference between the y coordinate. We divide it by the distance between the x coordinate to get our gradient of a straight line graph. Thank you very much. At the end of Good day, viewers. You are welcome to today's teaching. In today's teaching, we'll be looking at sine and cosine rule. Sine and cosine rule. This topic is very, very essential in mathematics because you can use this to solve bearing questions or questions on bearing, and you can also use it to solve questions on angle of elevation and then depression. Now, sine and cosine rule. Let's say we have this, an acute angle. For example, this is right angle here, another one here. Here we have A, here we have B, and here we have C. The main angles are denoted with capital letter. Angle A, angle B, angle C. Angle A, angle B, angle C. Now, this place will be denoted by the angle facing opposite side of the angle, the side rather, facing the opposite, facing the angle will be denoted by the corresponding small letter A. Then this side, small letter C. This side, small letter B. Now, in cosine rule, it is the small letter over the sine of the angle, which is equal to the next small letter over the sine of the angle facing each other. So using sine rule now, using sine. That means we are having A over, is the small letter facing the angle, that is sine A, which is equal to B, this one, this angle, B over sine B, which is equal to C. This C facing this angle, small letter C over sine C. That is for sine rule. Then when do we use sine rule? In what occasion? What is the condition in using sine rule? Sine rule is used when two angles at the side are given. Two angles at the side are given. Then sine rule can also be used when one side, and when the two sides rather, and one opposite angle facing one of the sides is given. Let me take that one. When two sides and one of the angle given is facing opposite side of one of the two sides. Now, what do I mean by that? For example, Example 1. In triangle ABC, angle A is equal to 40 degree and angle C, let me use this to denote it. Angle C is given as 70 degree and B is, that small letter B now, is given as 6 centimeter. 6 centimeter. Find A. Find A. When you look at this question, two angles are given and a side. Two angles are given and a side. So how do we solve this problem? Solution. This is, let's first sketch the diagram. The diagram of triangle ABC. ABC. Let's sketch the diagram here. This is our A. Let's say this is our B and our C here. So in the question, triangle A is 40. This place is 40 degree. In the question, C is 70 degree. Why this side is unknown, but we are given a side. That means that this place is A, this is C, small letter C, and this one is B. But B is given in the question to be 6 centimeter. 6 centimeter. Now we are to find A. We are to find A. Now, how do we solve this? We use a sine rule. Why? Two angles and a side are given in that question. So we use a sine rule. So in using sine rule now, we cannot use sine rule without getting the last angle here. This is a triangle. How do we get this angle? This angle, we need to find this angle. How do we find this angle? By the theorem of triangle, that the sum of all the angles in a triangle is equal to 180 degree. Is equal to 180 degree. Let's say B is unknown now. That is B plus 40 degree plus 70 degree is equal to 180 degree. So the reason is the sum of angles in a triangle is equal to 180 degree. So that means that B, angle B is equal to 180 minus 40 minus 70 degree. So that means we are going to have 180. When we subtract 40 from 180, we are left with 140. 70 from 140 is 70 degree. So that means that angle B is 70 degrees. So this angle becomes 70 degree. Now we are to find A using our sine rule. And what do we have in sine rule? We have it as A over sine A, which is equal to B over sine B, which is equal to C over sine C. We may not necessarily need all the three parameters. We may only need two here, going by that question. So that means our A, we are going to have A over sine, what is A? 40. Sine 40 degree, which is equal to B. What do we have in B? 6 centimeter over sine B. What do we have in B? That is sine 70 degree. So to get our A here, we do what? We cross multiply. To get our A here, we cross multiply. So if we cross multiply, what are we going to have? Or let's first look for what sine 40 is before we cross multiply. That means that we're having a over sine 40 is 0.6428. 0.6428, which is equal to 6 over sine 70 degree is 0.9397. 0.9397. Now from here we can cross multiply. We are going to have a over sine 40, which is equal to 6 over sine 70 degree. And what is sine 40? That will be a over 0.6428, which is equal to 6 over 0.9397. 0.6428 and 0.9397 is therefore sine 40 and sine 70 respectively. Now we cross multiply. So that means we're having a multiplied by 0.9397 is equal to 6 multiplied by 0.6428. So here we are going to have this one as 0.9397a is equal to 6 multiplied by 0.6428 will give us 3.8568. 3.8568. That is what we are going to have. That is 3.8568. We divide both sides by the coefficient of a, which is 0.9397. 0.9397. This one will eliminate this. Our a is equal to, when you press your calculator, you divide this one by this. So that means we are going to have 4.10 approximately. In what? Is it given in centimeter or meter? In centimeter. That is another thing you need to consider, in centimeter. So that is our answer to the question, that find A. In cosine, we have the following. We have a square, which is equal to b square plus c square minus 2bc cos theta. So looking for side A. Then looking for side B. B square is equal to a square plus c square minus 2ac. Let's use cos A here. Sorry, cos A. Cos B. B square equals to a square plus c square minus 2ac cos B. Then in the case of C, the third side of the triangle, c square is equal to a square plus b square minus 2ab cos C. Then if we are to find angle, you have to find angle. You have to find angle in a question like this. For example, you have to find angle A. You have to find angle A. That means that cos A, which is angle A, is equal to b square plus c square. This one, when it comes inside, when this cross that sign, it becomes a negative. That will be minus a square, everything over, divided by 2bc. That's for cos A. For cos A, you have to find A, everything divided by 2BC. 2BC. Then we are also going to have for cos B is equal to A square plus C square minus B square, everything divided by 2AC. 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 That is in the case of cos B, angle B. Then we have to find angle C. That one is given as A square plus B square minus the C square, everything over 2AB. So when you are looking for cos A, we have it as B square plus C square minus A square over 2BC. Then cos B is equal to A square plus C square minus B square over 2AC. While cos C is equal to A square plus B square minus C square over 2AB. Now, this is a question. Here we are going to use cosine rule. Why? Because in the question, two sides are given and then included angle. That is angle A, 60 degrees. Two sides in cosine rule, two sides and included angle. Then another condition where you can use cosine rule is when the three sides are given. When the three sides are given. Now, how do we solve this? Solution. In the diagram below, ABC is a triangle. So we have to look for A in that question. Angle A is 60 degrees, B 3 centimeter, and C equals to 5 centimeter. We have to find A using cosine rule. A square is equal to B square plus C square minus 2BC cos A. A square equal to B square plus C square minus 2BC cos A. That means that A square is equal to, what do we have in B? We have 3. That is 3 square plus, what do we have in C? We have 5. 5 square minus 2BC. 2 into bracket 3 multiplied by 5 cos the angle given is 60 degrees, cos 60. So that means we are going to have A square to be 3 raised to power 3 means 3 times 3, which is 9, plus 5 raised to power 2 means 5 times 5. We have it as 25. Minus 3 times 5 is 15. Multiplied it by 2, it will give us 30 cos 60. And what is cos 60? What is cos 60? That is multiplied by 0.5. Cos 60 is half, 0.5. That means our A square is equal to 9 plus 25. 9 plus 25 will give us 34. Minus half, when we multiply 30 by 0.5, it's like you are looking for the half of 30. That is minus 15. 30 multiplied by 0.5, it will give us 15. So that means that A square is equal to 34 minus 15. It will give us, when we subtract 15 from 34, it will give us 19. It will give us 19. So what do? We look for the square root of 19. We look for the square root of 19. The square root of 19. So A is equal to square root of 19. A is equal to 4.35. So approximately, we are going to have it as 4.4. So you look at it, if we have it in centimeter or meter. So we have them in centimeter. The three sides, they are in centimeter. The two sides given, they are already in centimeter. So that means that the last one will be also in centimeter. So at the end of this video, an assignment will be given, and in the next video, solution to the assignment will be provided. So do well to watch the next video. Do have a great day. Welcome to today's teaching. I'll be learning number basis. We have different number basis system. We have binary system. When we talk of binary system, we talk of base 2. Then we have octal system, that is base 8. We have denary system, base 10. Then we have duodecimal, base 12, and hexadecimal, and so on, and like that. Then we have conversion from one base to another, and we have different rules in solving problems under these conversion problems. Like, for example, converting from base 2 to base 10. The rule number 1 is to multiply each number by the power of the base. Conversion from base 2 to base conversion from base 2 to base 10. Rule 1. Conversion from base 2 to base 10. Here, we multiply each number by the power of the base, that is 2. For example, convert 101 in base 2 to base 10. We go with this rule 1. We multiply each number. That is, we label from the back. Solution. Write the number 101 base 2. You label from the back, then you start with 0. 1 and 2. What are we going to have? We are going to have 1 multiplied by 2 raised to power 2 plus 0 multiplied by 2 raised to power 1 plus 1 multiplied by 2 raised to power 0. And you remember, any number raised to power 0 is 1. This one will give us 1 times 2 raised to power 2. That is 2 times 2. That will give us 1 times 4 plus this one will give us 0 times 2 plus, like I said earlier, 2 raised to power 0 is 1. 1 times 1 will give us 1 times 1 will give us 1. 1 times 4, 4. plus 0 multiplied by any number is 0 plus 1. 4 plus 0 is 4. 4 plus 1, that is 5, base 10. Then you can also convert rule number 2 from base 10 back to base 2. From base 10 back to base 2. What do you do here? The rule says you divide. Divide by the base given. Now 5 in base 10, for example, you want to convert it back to base 2. Back to base 2, you divide by 2. That is root 2. Root 2. Divide, conversion from base 2. From base 10, sorry, to base 2. Divide by the base required. Repeatedly. And pick the remainder. Pick the remainder from downward, upward. What to upward. For example, that 5, for example, convert 5 base 10 to base 2. We want to get that number back to base 2. Going by the rule, we divide by 2. Solution: 5, 2. 2 in 5. That is, how many times will 2 go in 5? It will go twice. Then it will leave a remainder of 1. Remainder 1. 2 can also go in 2. 2 in 2. That is 1. Remainder 0. Then 2 in 1. That is 0. Remainder 1. You now read from that rule. You read upward. That means, therefore, 5 base 10 is equal to 101 base 2. We have gotten that back from base 10 to base 2. That is rule number 3. From decimal part, conversion of decimal part. Of number bases. In the case of base 2 to base 10, from base 2 to base 10, we multiply by the respective power. That is, conversion of 1, 0, 1. Let's have 111.101. That is in base 2 now, to base 10. This old part will follow the normal rule. That is 0. So solution: 111.101. That's 101 base 2. We follow, that is 0, 1, 2, minus 1, minus 2, minus 3. Therefore, we are going to have 1 multiplied by 2 raised by 2 plus 1 multiplied by 2 raised by 1 plus 1 multiplied by 2 raised by 0 plus 1 multiplied by 2 raised by minus 1 plus 0 multiplied by 2 raised by minus 2 plus 1 multiplied by 2 raised by minus 3. Here we are going to have 1 multiplied by 4. 2 raised to power 2 will give us 4. Plus 1 multiplied by 2 plus 1 multiplied by 1. 2 raised to power 0 is 1. Then plus 1 multiplied by, the interpretation of this in mathematics is the reciprocal. That is 1 over 2. That means we are going to have 1 multiplied by 1 over 2 plus 0 multiplied by 1 over, that negative sign is telling us that it's 1 divided by 2 raised to power 2 plus 1 multiplied by 1 over 2 raised to power 3. So 1 multiplied by 4 will give us 4 plus 1 multiplied by 2 will give us 2 plus 1 multiplied by 1 will give us 1 plus 1 multiplied, this one will give us 1 over 2 plus anything multiplied by 0 here will give us what? 0 plus 1 multiplied by 2 raised to power 3 means 2 raised to power 3 means 2 raised to power 3 means 2 times 2 times 2, and that will give us 8. 1 over 8. Now the whole part, we first add up the whole part. 4 plus 2, that is 6 plus 1, 7. Then we take this one is having LCM. The LCM here is 8. We take the LCM. What is LCM is 8. How many times will 2 go in 8? That means it will go 4 times. 2 multiplied by 1 will give us, 4 multiplied by 1 will give us 4 plus 8 into 8 will go 1 time. Then 1 multiplied by 1 will give us 1. Therefore, we are going to have 7 whole number. 4 plus 1 will give us 5 over 8. Then this one can also be expressed as decimal point. That is, how many times? That's 5 over 8. That is, 5 over 8 will give us 0 point. Add 0 to this. How many times will 8 go in 50? That is 6 times. 8 multiplied by 6. That is 48. Then it will leave a remainder of 2. How many times will 8 go in 20? That is 2 times, remainder 4. How many times will 8 go in 40? That is 5. So our final answer is 7.625. That means we are going to have our final answer now will be 1 point, that is 101.101 base 2 is equal to 7.625 base 10. Then rule number 4. When converting the decimal, conversion of decimal part of number bases, that is from base 10 now to base 2. From base 10 to base 2, we want to conversion from base 10 to base 2. Talking about the fractional part. For example, we want to add this one back to base 2. This one is in base 10. Example. Convert 7.625 in base 10 now to base 2. What do we do? The rule says that you first divide this, follow the normal rule, divide by 2, you multiply the decimal parts by the required base. Solution. 7. Let's first divide 7. The whole number part, that is the rule. The whole number part divided by 2, you multiply the decimal parts you multiply it by the required base. 7, that will be 3, leaves a remainder of 1. 2 in 3, it will go 1 time, then leaves a remainder of 1. 2 in 1, that will be 0, remainder 1. So that means that 7 that is in base 10 is equal to 1, 1, 1 in base 2. Now the fractional part, we have it as 0.625, that is in base 10. Remember that I said, since it's going to base 2, you multiply by the required base, which is what? 2. Multiply by 2. You repeat this. In the case of division, we read upward the other time here, but in the case of this one, we read downward. 2 multiplied by 5 will give us 10. Write 0 and keep 1. 2 multiplied by 2 will give us 4, plus that 1, 5. 2 multiplied by 6 will give us 12. We keep 1. 2 multiplied by 0, let's put our decimal point here. 2 multiplied by 0 is 0, plus that 1. Bring our 1 here. Then we repeat the same, we repeat it twice, but it is better to repeat it 4 times. 2, you multiply it by this, respectively, repeatedly. 2 multiplied by 0, 0. 2 multiplied by 5 is 10. We write 0 and keep 1. 2 multiplied by 2, that is 4, plus 1, 5. Put our decimal point. 2 multiplied by 1 is 2, but we are multiplying in that same number, in that same base. So we are not going to write 2. You look at it, divide it by 2. 2 multiplied by 2 is 2. How many times will 2 go in 2?
All right, so let's go.
Good day, students. You're welcome to today's teaching. Today we'll be looking at number bases. We have different types of number base systems. We have the binary system, talking of base 2 system. We have the octa system, base 8. We have denary system, base 10. We have duodecimal, base 12. We have hexadecimal, base 16, and so on and so forth. So, and we have conversion for one base to another, and we have different rules in solving them. Rule 1, conversion from base 2 to base 10. Conversion from base 2 to base 10, we multiply each number by the power of that required base, which is base 2. For example, convert 101 that is in base 2 to base 10. To base 10. How do we solve this? Going by that rule 1. Solution. You need number it from behind. So we number it from the back, and we start with 0, 0, 1, 2. Now the 1 multiplied by the base raised to power 2 plus 0 multiplied by the base raised to power 1 plus 1 multiplied by the base raised to power 2. Any number raised to power 2 is 1. That will be 1 times 2 raised to power 2 means 2 times 2, which is 4, plus 0 multiplied by 2 plus 1 times 1. One multiplied by 4 will give us 4. 0 multiplied by 2, as a matter of fact, you know that 0 multiplied by any number is the same thing as that 0. Plus 1 multiplied by 1 will give us 1. 4 plus 0 is 4. 4 plus 1 will give us 5. That means 5 base 10. 5 base 10. That is Therefore, 101 base 2 is equal to 5 base 10. Rule number 2, conversion from base 10 to base 2. Here, we divide by the required number, the required base number. Rule number 2, conversion from base 10 to base 2. We divide by the required base number. For example, we want to convert from base 10, 5 base 10, back to base 2. Example, convert 5 base 10 to base 2. Solution. Like I said the other time, the rule says divide by the required base number. And what is the required base number? Base 2. 5, 2. How many times will 2 go in 5? That is 2 times. It will leave a remainder of 1. 2 in 2, that is 1. It will leave a remainder of 0. Then 2 in 1, that will be 0. Remainder 1. We now read the remainder upward. That means that 5 base 10 is equal to 101 base 2. Then we also have conversion in decimal parts, from decimal parts. That is, like if we have conversion from base 2 that is in decimal parts, we multiply by the repeated power of the base. What do I mean by that? For example, convert 101.101 that is in base 2 to base 10. Solution. One 101 base 2 is. Now we are going to label. You start from here, the whole fraction part before going to the decimal point. 0, 1, 2. This you start with -1, -2, -3. And what are we going to have now? That will be 1 multiplied by 2 raised to power 2 plus 1 multiplied by 2 raised to power 1 plus 1 multiplied by 2 raised to power 0 plus 1 multiplied by 2 raised to power -1 plus 0 multiplied by 2 raised to power -2 plus 1 multiplied by 2 raised to power -3. 1 multiplied by 2 raised to power 2 will give us 4. Plus 1 multiplied by 2 will give us 2. Plus, remember that anything raised to power 0, it will give us 1. 1. 2 raised to power 0 is 1. 1 times 1, 1. Plus, the meaning of this -1 over 2, 2 raised to power -1 is 1 over 2. That is interpretation. The interpretation of that. Plus 1 multiplied by 1 over 2, which will remain as 1 over 2. Plus, as a matter of fact, you know that 0 multiplied by any number will remain as what? 0. Plus 1 multiplied by 1 over 2 raised to power 3. That means we are going to have the whole part will give us 4 plus 2, 6 plus 1, 7. Then the other part you discover we have LCM. 2 raised to power 3 here will give us 8. 2 raised to power 3 here will give us 8. Okay, 8 and 2. What is the LCM? We have it as 8. Here we give us 1 over 2 raised to power 3 is equal to 8. That means we're having 8 as the LCM. 2 in 8 we go 4 times. 4 multiplied by 1, 4. 8 in 8, it will go 1 time. 1 multiplied by 1, will give us 1. That means we are going to have 7. 4 plus 1, 5 over 8. This one can also be written as that 5 over 8. We can change it to decimal fraction. How many times will 8 go in 5? As a matter of fact, it cannot go in 5. You write 0 point. Bring 0 back to that 5. It will give us 50. 8 in 50, that is 6 times. 8 multiplied by 6, 48. It will leave a remainder of 2. It will leave a remainder of 2. Then that means we bring 0 to it. 8 multiplied by 8 in 20, that is 2. Then 8 in, it will leave a remainder of 4. 8 in 40, that will give us 5. Therefore, 101.101 base 2 is equal to 625 base 10.
All right, sir.
Let's look at the next question under equations in the number basis. For example, 126 base n is equal to 86. The question is, find the positive number of n. The positive number of n. Solution. So we number as usual 0, 1, 2. Okay, we leave this one. It's in base 10 already. So that means we are going to have 1 multiplied by n raised to power 2 plus 2 multiplied by n raised to power 1 plus 6 multiplied by n raised to power 0 equal to 86. 1 multiplied by n raised to power 2 is n raised to power 2, that is n squared, plus 2n. N raised to power 0 here is 1. 6 multiplied by 1, 6 plus 6 equal to 86. That means we're having an equation now. We collect like times. First, that will be n squared plus 2n equal to 86. When this one goes, it becomes what? Minus 6. That means we are having n squared plus 2n equal to 80. Now, this n squared is showing quadratic equation of this form: x squared plus bx plus c, which is equal to 0. Our quadratic equation. That means we're having n squared plus 2n minus, this one is positive here, comes inside, it becomes negative. 80 equals what? 0. We now solve this by factorization method. We can also use quadratic formula, but let's use factorization method. You remember in factorization, we say a multiplied by c is equal to ac. What is our a here? The coefficient of this one, which is what? 1 multiplied by minus 80, the constant term, and that will give us what? Minus 80. What do we do with this? We look for two factors of minus 80. That when you multiply, will give us minus 80, and when you add, will give us plus 2. And what are the two numbers? We look at 10 and 8. But the sign is not there yet. We need to look at 10 multiplied by 8 will give us 80. But we don't have ordinary 80, we have minus 80. So that means one we carry positive, while the other we carry negative. Then we need to consider this number, that when we add, we give us this. So that means we are going to have 10 minus 8. 10 minus 8 is like when you are having 10 naira and you are owing 8 naira. When you pay your debt, you will still have 2. 10 multiplied by minus 8 will give us minus 80. We now substitute this value as 10n and then minus 8n. Therefore, we are going to have n squared plus 10n minus 8n minus 80 equal to 0. We factorize by grouping. What is common here? N. That means we have n into bracket n into n squared, we have n plus n into 10n, we have 10. What is common here? The common factor here is 8 into 8n. We are left with n minus multiplied by minus will give us plus. 8 into 80, we have 10 equal to 0. Now the interpretation is n minus 8 into bracket. You pick one of these two. N plus 10 equal to 0. That means n minus 8 equal to 0 or n plus 10 equal to 0. The interpretation of this is, this one will cross this line. That means n is equal to 8 or n is equal to minus 10. Now look at what we have done here. What I've done here, n is equal to 8 or n is equal to minus 10. Number bases cannot be in negative form, so we discard this negative and we pick this positive. Therefore, the final answer, because even from the question says find the positive number. So n is equal to 8. That's what we've done. Now we are going to look at the equation leading to simultaneous equation. I mean number basis leading to simultaneous equation. For example, determine the number bases x and y in the following simultaneous equations. 32 base x minus 12 base y equals to 9 base 10. And 23 base x minus 21 base y equals to 4 base 10. Solution. The first one is 32 base x minus 12 base y equals to 9 base 10. This is equation 1. The next one is 23 base x minus 21 base y equal to 4 base 10, equation 2. In this question, that will be 32. Let's first deal with that equation 1 minus 12 base y equals to 9 base 10, which is our equation 1. Now we expand. Conversion to base 10 is expansion. 0, 1. So that means we're having 3 multiplied by x raised to power 1 plus 2 multiplied by x raised to power 0 minus, remember to put this one in brackets so that it will not affect your workings. So 1 multiplied by y raised to power 1 plus 2 multiplied by y raised to power 0, close the bracket, equal to 9, which is in base 10 already. So we take this one, okay, which is already in base 10. 3 multiplied by x raised to power 1 is 3x plus x raised to power 0 is 1. 2 multiplied by 1 is 2 minus 1 multiplied by y will give us y. Minus times plus will remain as minus. So y raised to power 0 is 1. 2 times 1, 2, which is equal to 9. What do we do now? We collect like times. So that means we're having 3x minus y plus 2 minus 2. As a matter of fact, plus 2 minus 2, you have 2 naira, you are owing 2 naira. If you pay your money, you don't have anything. So that is 0, equal to 9. So we take this one to be equation 1a because it's under equation 1. Then the next one, which is equation 2, 23 base x minus 21 base y equal to 4 base 10. This one is equation 2. We repeat the same step. What we have done here, So we expand this. That is, we convert to 10 to base 10. So that will be 2 multiplied by x raised to the power 1 plus 3 multiplied by x raised to the power 0 minus into bracket 2 multiplied by y raised to the power 1 plus 1 multiplied by y raised to the power 0, close the bracket, equals to 4. Now 2 multiplied by x will give us 2x plus x raised to the power 0 is 1. 3 multiplied by 1, 3, minus 2 times y will give us 2y, minus times plus will give us minus, 1 times 1 will give us 1, equal to 4. Now we are going to have 2x minus 2y equal to 4. This one is positive here. It becomes a negative. Minus 3 plus 1. That means we are going to have 2x minus 2y equals 4 minus 3. That is 1. 1 plus 1, 2. We are going to have 2x plus 2y equal to 2. You now discover that in this equation, 2 is common. We can divide 2. To make our work more easier, we divide by 2. 2, divide all through by 2. This one will go, we cancel this. That means we are left with 1 here. Then 2 into 2x, we have it as x plus y equals to 1. That is equation 2a. So that means the required equations are 3x minus y, which is equal to 9, equation 1a. Then x plus y equals to 1, which is equation 2a. Now, we can use substitution method, simultaneous equation, we can use substitution method, we can use elimination method, we can use graphical method, even we can use matrix method. Let's use elimination method. Elimination method. In elimination method, we want to eliminate one variable. So here we subtract equation 2 from 1. Subtract equation 2 from 1. What is the interpretation of that? That means that is 3x minus y equals to 9, which is equation 1a. Then we have x minus y, which is equation 2a. Now, what is the interpretation of this? You are subtracting equation 2 from 1. So minus here. 1 minus 9 will give us 8. 1 from 9 will give us 1 from 9 will give us 8. Then minus y, that is minus y minus y. That means it will give us minus y, minus times minus, plus y. So minus y plus y will cancel each other. So we are now left with x minus 3x. X minus 3x. And that means we are having 2x. We divide both sides by 2. Divide both sides by 2. Because we are looking for x. We divide by the coefficient of x, which is 2. 2 here, 1, 2 here. So 2 here, 1. 2 in 8, 4. Our x is equal to 4. Now we want to look for y. We want to look for the variable y. So to get variable y, we substitute x as 4 in any of the two equations, either equation 1 or equation 1a or equation 2a. Substitute x as 4 in, let's use equation 2a, in equation 2a. And what do we have in equation 2a? We have x minus y equal to 1. That is what we have in equation 2a. So anywhere we see x, we write it as 4. That will be 4 minus y equals to 1. So we collect like terms now. That means minus y is equal to 1. This one is positive here. It becomes what? Negative here. So minus y is equal to minus 3. This is not y yet. We're having minus y. So, and we're having minus 3. So we divide both sides by minus 1. By minus 1. This one we cancel this. This one we cancel this. So y is equal to 3. So the two bases are 4 and 3. That is, x is 4, y is 3. So that means we're having 32 base 4 minus 12 base 3 equals to 9 base 10. And the second one, we're having 23 base 4 minus 21 base 3 equals to 4 base